Right, from the shipyards, where these incredible feats of engineering are born to the open ocean where they rule the waves. Welcome to All Source Podcast. Today we're diving deep, deep into a modern marvel, a true titan of the seas, the Gerald R. Ford class aircraft carrier. If you're fascinated by the roar of jet engines, the complex ballet of flight deck operations, be sure to hit that like button, share this episode, and subscribe to All Sorts Podcast on YouTube so you don't miss out on future deep dives. For this one, we've scoured news articles, we've dug through government reports, and of course the official Navy websites to really get a handle on this beast.
Statistics, all right.
We're on a mission to uncover the key innovations, really understand what this class of carriers can do, and of course assess, where they stand today. So let's get into it.
Let's unpack this impressive piece of naval engineering. The Gerald R. Ford class, it's not simply a new ship. It represents a whole new way of thinking about carriers for the U.S. Navy in the 21st century. And to understand its significance, you really have to look back at what it's replacing, the USS Enterprise, CVN-65, and the Nimitz-class carriers that have been the backbone of the fleet for so long. The vision here is to create the ultimate forward-deployed asset, something that can respond to crises immediately and bring overwhelming force to bear in a major conflict.
So we're talking about more than just size here, right? This
Yeah.
is about a whole strategic capability shift.
Absolutely.
And our sources really highlighted a broad range of roles that these ships are envisioned to play, right? From just being there, being a visible deterrent to potential adversaries, to actively controlling the seas, projecting American power around the world, ensuring maritime security, and even, providing humanitarian assistance when needed. That's a pretty wide range of missions.
It is. It's designed to be incredibly versatile, a true multi-mission platform. But at its core, there are three main goals that drove the design. First, they really wanted to up the warfighting effectiveness, make it a significantly more potent weapon system. Second, they wanted to improve the quality of life for the thousands of sailors who live and work on these ships. And third, and this is, a pretty ambitious goal, they wanted to actually reduce the cost of owning and operating these carriers compared to the older generations. Now, as we get into the details, we'll see how those goals are actually playing out in reality.
Yeah, because ambition and reality often, have a complicated relationship. So let's get into the nuts and bolts, the what makes this class so different. I mean, it's the first brand new U.S. carrier design in 40 years, which is, in terms of technological advancement, that's a huge gap. What are the big headline improvements that set it apart from the Nimitz class?
Well, one of the primary focuses was a 25% increase in the sortie generation rate.
Okay, sortie generation rate. Break that down for us a little bit.
Yeah, that's essentially how many aircraft you can launch and recover in a given time period. It's all about speed and efficiency. The targets were pretty aggressive, aiming for around 160 sorties per day on a sustained basis, and then being able to surge up to 270 sorties if needed. Now, whether they can actually hit those higher surge numbers consistently, especially under, real-world high-pressure combat conditions, well, that's been something they've been evaluating very closely. And to be honest, it's still a bit of a question mark.
But that 25%, I mean, if they can actually hit that consistently, that's a game changer in terms of how a carrier strike group operates, right?
It could be, yeah. Imagine being able to launch significantly more aircraft in the first few hours of a conflict. You could potentially overwhelm enemy defenses, maybe even achieve air superiority much faster. But again, the testing is crucial to figure out if the theory actually translates into reliable real-world performance.
Okay, so a big jump in the tempo of operations, if they can pull it off. What other major changes do they incorporate?
Well, they made a massive increase in the electrical power generation capacity. I'm talking about roughly 2.5 times the capacity of a Nimitz-class carrier. And that extra juice is absolutely essential for running all the advanced systems we're going to talk about.
Makes sense, yeah. More power, more possibilities.
Exactly. And another key difference is they aim to reduce the number of personnel on board. They wanted to shave off about 500 sailors from the total crew, bringing it down to around 4,500, including the air wing. The actual ship's company itself is about 700 sailors smaller than on a Nimitz class. And the idea is that, automation and more efficient systems would make up for those fewer bodies on board.
Fewer sailors on a more powerful ship, that sounds pretty good, assuming the technology cooperates. Our sources mentioned a redesign from keel to mast. That sounds pretty comprehensive. Can you give us some specific examples of those fundamental changes?
Sure. I mean, they really did rethink almost every major system on this ship. First off, they've got these new A-1B nuclear reactors, which provide that big boost in power we talked about. Then there's the Electromagnetic Aircraft Launch System, or EMALS, which replaces those old steam catapults. Now, this is a really transformative change in how they launch aircraft off a carrier.
Yeah, emails, that's been getting a lot of attention. What are the key advantages it offers over those older steam catapults?
Well, for one thing, it provides a much smoother, more controlled launch, and that's important because it reduces the stress on the airframes of the aircraft, which is good for, keeping them flying longer and reducing maintenance. But maybe even more importantly, it can launch a much wider range of aircraft types, from very light drones, unmanned aerial vehicles, all the way up to, fully loaded combat jets. And because it's electric, it doesn't need all that steam, which means they need less fresh water, which is a very precious resource on any ship at sea.
That versatility, being able to launch pretty much anything, that sounds incredibly valuable, especially as aircraft designs continue to evolve.
Yeah.
What about landing? I remember reading about something called the Advanced Arresting Gear, AG.
Yeah, that's right. AG is what replaces the old hydraulic arresting gear that they used on the Nimitz class. It's kind of similar to EMALS in that it provides a smoother, more controlled landing, and that's better for the aircraft, especially those lighter drones, which, could be damaged by the harsher forces of the old hydraulic system. AG is also lighter, it's controlled by software, and it requires less manpower to operate and maintain.
Okay, so we've got a complete overhaul of how aircraft get on and off the deck. Now, the ship itself, visually it looks different, right? The islands, that command center structure, it seems smaller further back.
Yeah, you're right. That new, smaller island, they moved it further aft towards the back of the ship. And it might seem like a simple change, but it actually frees up a lot of space on the flight deck, which is really important for maneuvering aircraft, for doing maintenance, for staging, for flight operations. And the whole ship, it's designed to be all electric, which makes sense with all that extra power generation they've got. They've completely rethought the internal layout of the ship, how things flow, how to make it more efficient. They've even extended the flight deck itself to optimize aircraft handling. And one of the really cool things is they built in a lot of flexibility into the design. Internal spaces can be reconfigured pretty easily to adapt to different missions without having to do major structural modifications.
It sounds like adaptability and future-proofing were really baked into the DNA of this design. And I also read that this was the first carrier to be completely designed using a 3D product model, which has been a pretty big deal in terms of, the design and construction phases.
Yeah, it was. It was a real departure from how they used to build ships. That 3D model, it let them visualize all the complex systems so much better, which in theory, reduces conflicts during construction, makes everything more accurate. And we can't forget about all the sensors, the self-defense capabilities, the dual band radar, or DBR. That's a really important part of the Ford class's sensor suite.
Okay, DBR. Break that down for us. What makes it so advanced?
Sure. So the dual band radar, it basically combines two different types of radar into one system. Think of it like, you've got a camera, a very focused, high-resolution camera. That's the X-band radar, specifically the ANSPY3. And that's used for tracking individual threats very precisely. And then you've got a wider, more panoramic camera that was initially the S-band radar, the NSPY4, and that's for scanning large areas and picking up threats early on. By combining those two capabilities, the ship can, maintain detailed tracking of specific targets while also having a really good overall picture of what's going on around it. And it does all of that with fewer separate radar antennas, which is one of the reasons they were able to make that island smaller. But there's also an interesting evolution happening here. So on the USS John F. Kennedy, CVN-79, and the ships that come after that, they're actually replacing that S-band component with a more advanced radar, the ANSPY6. And there's even talk of retrofitting the Gerald R. Ford itself with a different system called ESR, the Enterprise Air Surveillance Radar. So you can see how they're constantly refining and adapting these very complex technologies.
It's like a high-stakes game of technological leapfrog.
Yeah.
So we've got this incredibly advanced sensor suite, but what about actually moving all the weaponry around inside this floating fortress? I remember something about using electromagnetic fields for the weapons elevators.
Yeah, that's the Advanced Weapons Elevators, or AWEs. They use linear induction motors and electromagnetic fields instead of those old cables and pulleys. And what that does is it lets them move bombs and missiles from those magazines deep inside the ship up to the flight deck much faster, much safer. And that speed is really important for hitting those higher sortie generation rates we talked about. Plus, those electromagnetic elevators need less manpower to operate and maintain compared to the old mechanical ones. And, for safety, the elevator shafts have these horizontal doors that can seal off the magazines in case of an emergency, which makes the ship more survivable.
Okay, so we've covered a ton of cutting-edge technology packed into these ships. Let's shift gears and talk about the ships themselves, their current status. First up, the lead ship, the USS Gerald R. Ford, CVN 78.
Okay, so the USS Gerald R. Ford, it was ordered back in September 2008, laid down in November 2009, and commissioned in July 2017. It's home ported in Norfolk, Virginia. It wrapped up its first deployment back in October 2022 and completed its first full-length deployment in May 2023. It officially achieved initial operational capability, or IOC, back in December 2021. And throughout fiscal year 2023, it's been doing a lot of flight operations, really putting its systems through their paces in real-world conditions.
So it's out there, it's actively serving in the fleet. But I've also seen reports that operational testing has been extended maybe even into March 2025 or beyond. What's the story there? Why the extended testing period?
Well, bringing together so many new and complex technologies, it's had its challenges, let's just say that. There have been some reports about reliability issues with a few key systems, things like the advanced arresting gear, EMALS, those advanced weapons elevators, and even the dual-band radar.
Okay, reliability issues with systems that are pretty crucial. That sounds like a pretty big hurdle to overcome. Can you give us some specific examples of the problems they've run into?
Sure. During one of the COMP-P2UX exercises, that's a composite training unit exercise, it's basically designed to certify a carrier strike group for deployment. Well, during one of those, they reported that the dual-band radar wasn't available as much as they'd hoped, compared to what they'd seen in developmental testing. And because of that, they've had to rely more on contractors for maintenance, which is never ideal. And there are some concerns about, getting replacement parts in a timely manner as the system matures. There's also some preliminary data that suggests the advanced weapons elevators might not be meeting their operational availability requirements at this point. And, they even found out during one of the COMP-P2Xs that they didn't have enough berthing space for everyone, which is, kind of a basic thing you'd think they'd have figured out. On top of that, the total ship survivability trial, that's where they really put the ship through the ringer to see how well it can handle battle damage. Well, that's been pushed back to the fourth quarter of fiscal year 2024. And they're not planning on doing live missile fire tests until fiscal year 2025. And as we talked about before, there's that possibility of retrofitting the ESR radar system down the line. So, it's a lot of moving pieces, a lot of ongoing testing and tweaking. And then on top of all those technical challenges, there have been some reports of, persistent problems with the ship's plumbing, specifically the waste management system. Apparently it gets clogged a lot, which leads to, some pretty unpleasant and costly cleaning operations.
It sounds like the Gerald R. Ford is still very much in that phase of, working out the kinks, the inevitable teething problems that come with being the first of a brand new class, especially one with so many new technologies. So what about the second ship, the USS John F. Kennedy, CVN 79? Are they taking what they've learned from the Ford and applying it?
Oh, absolutely. They're learning as they go, which is, part of the process. The USS John F. Kennedy, it was laid down back in 2013, and right now they're saying it'll be delivered in July 2025. It's going to be home ported in Everett, Washington. And the good news is they're building it with, all the lessons learned from the Ford. They've improved the shipyard processes, trying to make things more efficient and avoid some of the problems they ran into. And as we mentioned, it's going to have the Enterprise Air Surveillance Radar, or ESR, instead of that S-band component of the dual-band radar that the Ford has. They've also adjusted the cost limitation baseline for the Kennedy to make it more realistic. And of course, once it's delivered, it'll go through its own rigorous follow-on operational testing and evaluation period.
So the design and construction process is evolving, adapting based on real-world experience. That's crucial when you're talking about a first-in-class ship. Now, what about the next two in line, the USS Enterprise, CVN 80, and the USS Doris Miller, CVN 81? Those are pretty powerful names. A lot of historical weight behind them, especially the Doris Miller, the first carrier named after an African-American sailor.
Absolutely. Those names carry a lot of significance. So the USS Enterprise, CVN 80, they laid that one down in 2018, and right now the projected delivery is September 2029. Now that actually represents a bit of a delay, something like 18 to 26 months later than they originally thought. And a lot of that has to do with challenges with the shipyard workforce, supply chain disruptions, things like that. It's going to be home ported in Norfolk. Now, the USS Doris Miller, CVN-81, they procured that one in fiscal year 2019, and they actually bought it as part of a two-ship block buy with the Enterprise. It's scheduled to be delivered in February 2032. And that two-ship block buy strategy, that was all about trying to save money compared to buying each ship individually.
Ah, a block buy. That's where they basically commit to buying multiple ships at once to get a better price, right? Leverage some economies of scale.
Exactly. By negotiating a single contract for both the Enterprise and the Doris Miller, the Navy and the shipbuilder Huntington Ingalls Industries, they were hoping to shave a significant amount off the total procurement cost. And there's even been talk about maybe doing a similar two-ship block buy for the future CVN-82 and CVN-83, but that's still up in the air.
Yeah, cost is always a major factor, especially with projects of this scale. What's the overall estimated program cost for the whole Gerald R. Ford class?
Well, back in fiscal year 2018, they estimated the total program cost to be about $37.3 billion. Now, the cost per ship, that varies depending on the specific ship and any changes they make along the way, but in FY 2018 dollars, it was around $12.998 billion. To give you a little more detail, the USS Gerald R. Ford itself cost about $13.3 billion. The USS John F. Kennedy is estimated at $12.9 billion, the USS Enterprise at $13.7 billion, and the USS Doris Miller at $14 billion. But keep in mind, those numbers can fluctuate because of things like inflation, modifications during construction, and the unexpected issues that pop up.
It's a lot of money no matter how you slice it.
Yeah.
So those savings from the two-ship block buy for the Enterprise and the Doris Miller, those must be pretty substantial to justify going that route.
Oh, they are. According to the Navy's budget documents from FY 2020, they were projecting that the two-ship block buy would save them roughly $246.6 million on the USS Enterprise and a whopping $2.6 billion on the USS Doris Miller. So that's almost $3 billion in total savings compared to what they would have cost if they bought them separately based on FY 2019 estimates. And if you look at some of the earlier cost projections, the estimated savings were even higher, like around $4 billion.
Wow, okay, so that really shows the potential benefits of this block buying strategy, especially for these big, complex purchases. But I also came across some concerns about, maintaining the industrial base, the shipyards, the skilled workers who build these things, if the schedule for ordering new carriers gets too erratic.
Yeah, that's a real concern. You see, Huntington Ingalls Industries, their Newport News shipbuilding yard, that's the only place in the entire United States that can build these huge nuclear-powered aircraft carriers. And for them to keep those highly skilled workers, to manage their supply chains, to keep investing in all the specialized equipment they need, they really need a stable, predictable schedule of orders. If there are big gaps between orders or if the future's too uncertain, that can really disrupt the industrial base. And that's one of the main arguments people make for consistent procurement, for using those block buy contracts. And then on top of that, there have been some recent reports, investigations actually, into faulty welds on some new Navy ships, including some of the Ford-class carriers. That's obviously a big concern. Could impact construction schedules and costs.
Faulty welds on ships like this, that's serious stuff. Potential safety implications there.
Absolutely. And both the Navy and Congress are taking it very seriously. They need to make sure these ships are built to the highest standards.
Okay, so looking ahead, what's the long-term vision for the Gerald R. Ford class? I know the Navy wants to eventually have 10 of these carriers.
That's still the plan, yeah. 10 Gerald R. Ford class carriers to replace the existing fleet one for one. And the Navy's requirement is to have at least 11 operational carriers at any given time. And the focus going forward is going to be on achieving that higher sortie generation rate, being able to operate at a high tempo for a wide range of missions. And we're also going to see these carriers integrating new aircraft, things like the F-35C Lightning II, which is a stealth fighter, and unmanned aerial vehicles, drones like the MQ-25 Stingray, which is a tanker, and those new aircraft are going to really expand the capabilities and the reach of these carrier strike groups.
So the Gerald R. Ford class, it really does seem like a massive investment in the future of American naval power projection, a real evolution in carrier technology.
It is. It's a real statement about their commitment to cutting-edge technology, to pushing the boundaries of what a carrier can do. But as we've talked about, it's been a challenging journey to get to this point. They're still testing, evaluating, refining these ships, and that's going to be critical to determining how successful they ultimately are.
Well, this has been a truly fascinating deep dive into the world of the Gerald R. Ford class aircraft carrier. I mean, it's incredible to see the technological leaps they've made, but it's also really interesting to understand the complexities, the challenges that come with bringing such ambitious projects to life.
I agree. It's a story of engineering, innovation, adaptation, and, that constant drive to maintain naval superiority in a world that's constantly changing.
So to sum it all up, the Gerald R. Ford class, it's a technological marvel. It promises those higher sortie rates, more electrical power, a smaller crew. But it's also a platform that's, had to navigate some pretty significant challenges with integrating all those new technologies and making sure they're reliable.
Exactly. It's a powerful symbol of naval ambition, but it's also a reminder that even the most sophisticated systems, they need to be tested rigorously, they need to be continuously improved. There's no such thing as perfect on the first try, especially with something this complex.
And on that note, we want to leave you, our listeners, with a question to ponder. Considering all the advancements, all the hurdles we've talked about today, what do you think the long-term impact of the Gerald R. Ford class will be on the balance of naval power, on global security? What questions do you still have about the future of naval warfare and the role these magnificent carriers will play?
It's definitely something to think about. The future of naval warfare is evolving rapidly, and these carriers are right at the forefront of that evolution.
And speaking of exploration and discovery, if you've enjoyed this deep dive into the world of naval innovation, make sure you keep the journey going. Head over to All Sorts Podcast on YouTube, hit that like button, share this episode with your friends, and subscribe to our channel so you don't miss out on future deep dives. We've got a whole library of past podcasts covering all sorts of fascinating topics. And if you want to stay connected, suggest future topics. Be part of the conversation. Be sure to follow All Sorts Podcast on X, on Instagram, and on Threads. Until our next deep dive, keep that thirst for knowledge alive, folks.
Keep exploring, keep asking questions. There's always more to learn.